Alright, I am not able to be with you this morning, but I'm going to give you a little bit of a video of where we were yesterday. We're going to start back here on this notepad document where we typed out our first version of pseudocode, our fake code, and we're going to move that over into Robot C. I'll review setting up your programming language, download settings, and also we'll talk about how to toggle comments, and how to start writing commands for this. And if we have time, we're also going to get into what it looks like to download this to your mini base plate, your mini testbed robots. All right, here we go. So here's our pseudocode. I'm at home making this video. I have to stay home with one of my kids tomorrow, and I don't think I probably have the exact same pseudocode that I showed you today in class. But we do have our name, date, title for our program, and our objective. Now, one thing I've added in that we didn't have in there today was start a motor and run at half speed. And so down here in my pseudocode section, it says turn on motor, run at half speed, press button, stop motor. Okay, now before we can use that, over here in Robot C, there's a couple things we need to do to set it up. First of all, we're going to do a new file. Get that opened up. Here we are, source file 2. Notice right away we show up, we have task main. When you work, make sure you keep task main. So here in a minute, we're going to put our pseudocode up here into this. Before we do, one of the things we did in class is we went here and set up our platform type. So selecting robot, going down to platform type, we want to make sure that we're selected VEX 2.0 Cortex and natural language. You may find that you're here in the IQ menu, and if you do, when you click on platform type, it's going to look like this. So what you'll need to do down here is make sure you change that to VEX 2.0 Cortex. Once you do, and you go back here again, you'll have that option to select natural language PLTW. Okay, we got everything we need. Now over here are our functions that we'll use. Most of the ones we're going to use for this program are found under our natural language inside the movement, start motor, stop motor, or over here inside our wait, until. Okay. First thing is to get our pseudocode into this program, so we're going to go back to our notepad document and highlight all that. We're going to Control-C copy. We're going to go back over here, and then up at the top, I'm going to use Control-V, and we're going to paste that in. Alright, now, I put a line here just to kind of keep things organized. We notice, first thing is that several parts have been colored automatically by Robot C, because the word motor, the word start, the date/number format looks like code to Robot C, and so it's automatically identifying those as variables inside its library. We don't intend them to be variables, so we're going to highlight all that. We're going to right click and say toggle comment. We'll turn everything that we've written into a comment that we can use just as our pseudocode. And we're also going to take this section here, we're going to copy it, we're going to put it down here. And it's going to form comments inside the line-by-line code to help us find problems later on, and just to help to explain what our code is supposed to be doing. Okay, so we've got our language set up, we have our comments and pseudocode set up, but this would be a good time to stop and save so we don't lose things. Save as. My computer right now is grumpy because I'm not connected to the network, and it's looking for the network file. So hopefully here in a minute it opens up that save as box and we can put it somewhere. Okay, for tonight I am going to be saving this into my desktop. If you are at school, you definitely want to be saving that into your network drive. This is moTorproGram 1, and I'm going to take that PS off of there because it stands for pseudocode. I'm just going to call this moTorproGram 1. Save. Okay. The next step with this that we did in class is to run through the motor and sensor setup. This is going to create the variables that will explain what our motors are. Now, on that mini test platform that you're working with, we have one motor and it's plugged into port 1. We talked yesterday about changing the capitalization of these names so that they aren't confused with other things within the program. We're going to call that motor 1. And it's a VEX 393 motor. And we're going to apply. Now, moving down. Now, good, we have a practice statement. I think most of you had this done yesterday, so we're going to go quickly over here to digital sensors. And over here, our first digital sensor is our button. And I'm just going to call this button 1. Button 1. And that is a touch sensor. Okay, and this is that button that's attached to that plate. We're going to click apply and OK. Okay, here we are. This is what we got through yesterday. We have our program set up, and we're going to hit save real quick to save our motor sensor setup. We have our digital port, our button, and our motor port. Remember, our digital sensors have two possible conditions. They can be on or off. In code, that's represented by 1 or 0. That's different than an analog sensor, which gives us a variable range of possible things it could tell us. And then, of course, here we have motor 1. It's on port 1. It's motor 1, and there's a type of motor. Okay, today you need to actually do the code. So turn on motor. What we're going to do is we're going to start working in this space right here, and we're going to go to our movement section of the natural language function library. We're going to drag our start motor option over here, and we're going to put it right in front of turn on motor. Now, we actually want that turn on motor to show up there at the end of the line to help us out. Now, start motor. First thing we notice is we need to identify the motor port. Up here we have only one motor, that's motor 1. So we're going to enter that here. Of course, we want to make sure we keep our spelling exactly the same. If we spell it differently, the program will recognize it as a different thing. So, motor 1. Now, speed. You can program the VEX 393 motor to any speed between 0 and 127, or 0 and negative 127. Negative speeds will have the motor running in the opposite direction. It's because in a DC motor, a negative current simply makes the motor turn the opposite way because it's reversing the polarity of the magnets inside the motor. So we can use any of those values. We're looking for a half speed, and up here it says we're on at half speed. We haven't identified forward or backwards. We're going to assume forward. So half of 127 is about 63. We're just going to round up there. So we have start motor, motor 1, 63. That's running forward now at 63 speed. Alright, now interestingly, that took care of 2 of our lines of code with 1 command. So we're going to take that little bit of comment and we're going to bring it up there. We'll have both those comments on the same line. Now, press button. One of the codes that we're going to use here for our start motor is actually an until. Now, you have to be careful with an until because it is a hard stop. When you use any of these until bump, until button, until dark, that forces the code that you've written to wait until that thing happens. For this program, it's a fairly simple program. We're going to use the until bump. I'm going to put that there. I'll talk more in class about the difference between until bump and until touch. But for right now, we're going to be using until bump. Now, our sensor port is button 1. Now, you notice I messed up my spelling. I'm going to have to fix that for the compiler to recognize when it goes through the code. Now, button 1, delay time in milliseconds. This is useful because on your button, there are times when you want to press a button on a machine, but you want a little bit of time to move your hand out of the way before the machine actually starts or stops. So, that delay time in milliseconds, I'm going to write a delay of 500. Now, 500 milliseconds is 1/2 of a second. It's not long, just long enough to kind of press the button and start moving my hand out of the way. Okay, so we have press button. That's what we intend to do on this line. Our code says we're going to use the until bump command, which is button 1 and 500. Button 1 is the parameter. The parameter specifies what we're doing with that simple command here. You notice that a parameter exists inside a set of parentheses. There's 2 parameters for this function. We have the parameter of which sensor is being used, and that's button 1. We have a comma and the second parameter of time that we're waiting. And then every command line should be ended with a semicolon. If you miss that semicolon, you will get an error message. Alright, so next thing, last thing, stop motor. So we're going to go up here, we're going to grab our stop motor, we're going to slide it in front, and then we're going to move that comment back up in front of it. Okay, we only have one motor, so the motor that we want to stop after we've let that until bump go for a little bit is motor 1. And I keep instinctively capitalizing that, but we're going to change that, motor 1. Now, you notice that the stop motor command has only one parameter that it's asking for. Unlike start motor, which asks for 2 parameters, it asks you what motor you're starting and how fast you want to run it. Stop motor simply asks, what motor do you want to stop? We don't need anything else. We don't need a time. We don't need a speed. We simply need to know which motor. Okay. We have written the command for every single line of our pseudocode, and we've finished out our program. One thing you should do at this point is use this button here, and it fixes your formatting. When I press that, you'll notice that some automatic indents occur here inside my commands after my opening curly brace and before my closing curly brace. This will be useful in debugging code. That fixed formatting will help to indent your code over and help you to see different things, command structures, conditional statements within your code. Okay, at this point we can hit compile. And if you have no errors, what you'll see down here in your compiler errors box is simply says file, and it will list your file and location, and it will tell you when it compiled. Now, let's play with it a bit. And if you notice, if I remove one of my semicolons and I hit compile, well, now I have an error, missing semicolon. Alright, so let's replace that. Compile. Now, for instance, if I spell my motor wrong and I hit compile, it's going to give me a warning. It says substituting similar variable. And so what it's saying is we think we know what you want to do, and we're trying to help you out. Now, if I start to, some of these errors that I could create are going to give me more problems. So right here, all I've done is gotten rid of one of my opening parentheses by accident. And if we notice when we do that, simply removing that one opening parentheses creates a whole list of errors. One of the errors is now what was a command is no longer, it doesn't recognize it, it doesn't know what this big long string of letters is. And so it's created a whole series of errors. And when you get this series of errors, it may be as simple as just returning that opening parentheses to your command parameter. And we're going to compile that program. There we go. Okay, now you have your program compiled. If you have time, you might want to try to run this on the test platforms. Students that took class last year will know how to set these platforms up, attach batteries, and access the orange download cords. Before you run it on your test platform, you may need to update your Cortex. To do that, you're going to go to Robot, you're going to go to Download Firmware, and you're going to select Automatically Update VEX Cortex. And select OK. Now while that's updating, I'm going to pause this recording for a minute. Okay, if you've successfully updated your Cortex, you're going to see this message. You can click OK. We're ready to download our program. We need to set our Cortex communication mode to USB only. So before you download your program, go to Robot, Cortex communication mode, and USB only. Once you have that selected, you can download to your Cortex. One thing you want to check is that your Cortex is turned on, that your USB cable is plugged into your robot. At that point you can download. You'll go here, you'll select download. Once your program is downloaded, you'll see this program debug screen here, and you can click start. When you click start, you should see the motor start running if you have written a successful program. And if your motor runs, you can press the button and it should stop your motor. If not, go back to your code, check it out, see if you can figure out what's wrong. Have fun, I hope it works. We'll hopefully see you tomorrow.